Alright guys, so this is the 2.5 lesson. If you'd like, you can follow along in the textbook, but I would just kind of follow along in the notes here, and you guys will be able to keep up just fine. If you want, you can kind of pause if you need some time, but I'm going to kind of go through this quickly so that I can get these videos done. And again, you guys can pause at any time if you want to try an example before you see me work it out in here. So again, just keep that in mind. I will explain my way through these so that you can see how they're done and kind of hear like you would if I were in class teaching it. So this first thing up at the top of the page, we have a key concept box. Most of us have seen the distributive property before. What we do is basically take this A and we multiply it times B, and then we multiply it times C. And a lot of times you'll see me take this and write these little arrows to show that I'm distributing. I take A times B plus A times C. And again, that's same thing here. Even if the number is on the outside to the right of the parentheses, it's still A times B plus A times C. Again, we have to watch our signs because we are multiplying, so if it's two positives, it's still going to be A times B, but positive A and negative C is going to make that a negative term, so it'll be minus A times C, and the same thing the other way. Again, I didn't really fill out the things on the right. You guys can do those if you'd like, but I'm going to kind of continue on into the examples here, and you guys will see how they're done as we go. So this first set of examples here, again, I'm going to keep drawing these arrows through so that you can see it done. But again, the operation we're doing here is multiplication. Up top on the right, it doesn't really look like we need to distribute. It looks like we're just avoiding order of operations. But here, we cannot combine y plus 3. But we can take this 4 through the parentheses and combine some stuff there. So when I take 4 times y, I can write that as 4y. And then I write plus 4 times 3. Again, I write this just to show you that we do need to take it times that second term also. Then we can actually simplify this down to 4y plus 12. If you guys would like to pause it, you can. I'm going to continue working these out. So I distribute the y through the parentheses. We need to keep in mind that y times y is y squared, not 2y. 2y would be y plus y, so don't make that mistake. I have several students do that. Then I have 7 times y, I write plus 7y. That's all the farther we can simplify it, simply because these aren't like terms. This y has an exponent of 2, this y has an exponent of 1. That would be like saying 25 and 5 are the same thing, and they're not. So next problem we have here, we distribute the n. N times n is again n squared. Negative 9 times n is going to be negative 9n. Notice that when I go to write this second term, I don't write the sign down until I distribute the second number because it determines this sign right here. And here's another good example right here on D. We take 8 through the parentheses. 8 times 2 is 16. I wait to write my sign. Negative n times positive 8 is negative 8n. And that is as simple as those go. So this first part's pretty easy. You guys should be able to handle it just fine. Example 2 is very similar. We're just distributing numbers that may be negative or terms that may be negative, but it's the same process. You're taking a number through a given quantity, so I have a negative 2 times positive x, and that's going to be a negative outcome. I wait to write my sign. I take negative 2 times positive 7, and I get negative 14. That's as far as we can take it. This one's done. That's good there. Next one, this is actually the term over here that I want to distribute. I go ahead and do that. I'm going to say negative 3y times positive 5, and I get negative 15y. Then I take negative 3y times negative y. Since it's a negative times a negative, it's going to end up being positive 3y squared. Again, don't forget the squared, because we have a y here and a y here, so it should be y squared for our outcome. We saw this on Thursday when we were working with this, you guys. When we have that negative sign out in front, really what's there is a 1. So what I'm going to do is take that negative 1 through the parentheses. This is similar to what we saw when we were working with opposites and absolute values. We had a problem last week where we said if a equals 7, find negative a. Well, basically what we're doing here is we're taking -1 and multiplying it. So really all that's going to happen is everything inside the parentheses is going to change signs. Okay, so instead of 2x minus 11, it's going to be -2x plus 11, and that's as far as we can take that one. Next up here we have some different things. When we go to simplify expressions, we have to learn about terms, like terms, coefficients, and constants so that we can combine and simplify expressions. So this first piece up here, what we're going to write is the word terms. Each one of these things in this expression, each one of these individual pieces is called a term. Down below we have the arrow pointing to the negative sign and to the 2, and it's referring to what's in front of the variable there, and everything that's in front of a variable is called a coefficient. Okay, and then we also have this 8 out here that doesn't have a variable. Any number in an expression without a variable is simply called a constant. Okay, so we're going to go ahead and continue on through these examples. The parts of an expression that are added together are called like. Things that you can combine are called like terms. The number part of a term with a variable part is called the coefficient of the term, and we already talked about that. So I'm just going to fill in that blank. Like terms are terms that have the same variable parts. Again, they're going to have the same variable parts, whether it be x or whether it be no variable at all, or whether it be x squared. It has to be the exact same for you to be able to put them together. So we actually have a couple like this in our homework where it's very simple. We are given an expression that looks like A or B, and what we have to do is identify terms, like terms, coefficients, and constants, and it may even say to simplify when you're finished. So make sure that you do all those parts. So what I'm going to do here is start by just listing out and writing out these different abbreviations. So my terms, what I want are all the individual components of this. Now when I write out my terms, I need to keep whatever sign it is. So the 3x is positive, I'm just going to write positive 3x. That 4 has a negative sign in front, I have to write -4. The 6x has a negative sign, I have to keep it with it. And the 2 is positive, so there it is. Next I have like terms, and those are the terms that can be put together. So again, they have to have the same variable part. 3x and -6x have the same variable part. Also, -4 and +2 have the same variable part. And again, they don't have any variables at all, but I can put those two together. The next piece, I have coefficients, and coefficients are simply the number in front of a variable. So 3 is in front of an x, and the other one is -6. Last, I have constants. Okay, and again, those are just the ones without variables, so my two constants are -4 and +2. Then I'm going to go ahead and simplify here like we would in our homework, so we need to put together the ones with like pieces. 3x and -6 are like, they have different signs, so I subtract and I get -3x. -4 and 2, again, those have different signs, I subtract and I get 2. I keep the negative sign from the 4, and this is actually the simplified expression from that. So again, if you want to try all of these parts and do that before you watch the next segment of the video, you can. I'm going to go ahead and start on it. So we have terms, -2x, -8, 6x, and 5. Like terms, we have -2x and 6x. Then we have -8 and 5. Coefficients, we have -2 and 6. Constants, we have -8 and 5. Then if I simplify that expression, it's going to end up being 4x minus 3. Again, my like parts are right here and here. Then I have another set of like right here and here. So that's all we have for that second piece. Last thing we have here, guys, is just kind of combining, simplifying the expression and distributing. So I'm going to go ahead and show you this first example, then you guys can try the second one before you watch me do it. So I'm going to take the 4n through, and I'm going to take it through to both numbers. If you guys want on the same line, you can take that -3 through the second set of parentheses. Just make sure you keep your signs correct. And what I'm going to do here is actually I'm going to change that color so that it's a little easier to see. I'm actually going to do a second distributing problem here. The first set, I have 4 times n. They're both positive, so my result is going to be positive. 4 times 9, both positive, so my result is going to be positive 36. Then for my second set, I have -3 times positive 2 is going to give me -6. -3 times n is -3n. Then all I do is basically combine like terms. So I have an n here and an n here. Then I have a constant and a constant. So I'm going to combine all those. 4 minus 3 is going to simply be n, or you can put 1n. 36 minus 6 is going to be plus 30. And that is the expression simplified. Again, I'm going to work out the other one a little bit quicker, but again, you can try this on your own before you watch. So I take the 6 through and I get 6x plus 18. I take the -2 through and I get minus 16 minus 2x. I combine like terms and I get 4x minus 2. And there's my answer to that one. So again, we watch for our signs, and it shouldn't be too tough. Last one here, if you read through this problem, it talks about a workout program being 50 minutes long. I'm going to turn this into an equation before I go ahead and plug in 20 minutes for R. So I'm going to leave 20 minutes out to begin with. What we do know is that we burn 15 calories per minute of running. And we also know that we burn 9 calories per minute when we're not running. And we know that the total workout is going to be 50 minutes. So I'm going to write this piece of the expression as 50 minus R. Again, if we run for 30 minutes, then I'm going to say 50 minus 30 to equal 20 for this piece. And that's just going to be our general equation for any given R of minutes run. So what I'll do here now is take this 9 through the parentheses and get this to an expression where I can just plug in the variable and go. I still have the 15R over here, plus 9 times 50 is 450 minus 9R. I simplify this variable expression. I get 6R plus 450. I plug in 20 for R, and I have 6 times 20 plus 450. 6 times 20 is going to be 120 plus 450, and whoops, and if I add those up, I'm going to get 0.75, so it'd be 570 calories. Okay, and now what I'd like you guys to do is go ahead and go to the quizzes folder in eBackpack. So you'll go to Algebra Chapter 2 quizzes and do the 2.5 quiz for tomorrow, and go ahead and make sure that that's submit before class tomorrow. Thank you and have a nice day.